Assalamualaikum and very good morning. Selamat sejahtera to all of you. So today we want to proceed to discuss the subtopic, the combination of a few capacitors in series and parallel. Alright, by looking at two different diagrams here, okay, so this is the capacitor in series. This arrangement are capacitors in parallel. Okay, now how can we identify the arrangement of the capacitors are series or parallel? So how? So the simple way how to identify either series or parallel by looking at the diagram. Okay, now this is the battery here. The battery, this one your positive terminal, this one is negative. Same with this diagram. Okay, so what happened? So the current, okay, will flow from positive to negative terminal. Now, by looking the direction of current, so this current will flow same through the capacitor 1 and capacitor 2. Am I right? And then finally, back to negative terminal. So, by looking at the direction of the current here in one way, meaning the combination C1 and C2 are series. Now, what happened to the combination of parallel capacitor? Okay, let's say, just imagine or draw, this is the current from the positive terminal, and then this is the same current. This is the junction. What happened to the current when reach the junction? The current will be split into two. Okay, one here, another one here. So meaning this current can be labeled as I1 and this is I2. So these two current, okay, is a different current. So meaning this I2 is not equal to I1. So therefore, these two combinations are parallel. Okay, next. Calculate, look at the tips here. To calculate effective capacitance, so effective capacitance is CF. It is easier to solve from the end of the circuit, meaning the capacitor that are far away from the voltage. Okay, next, look at the diagram and the concept. For the series effective capacitor, the formula is 1 over CF equal to 1 over C1 plus 1 over C2. The voltage here is a total voltage. V1 plus V2 meaning this is V1, this is V2. V1 plus V2, so we will get V total. Okay, total charge. When the current flow from C1 equal to C2, meaning the charge C1 equal to charge Q2, C2, meaning the total charge become Q1 equal to Q2. And the last part, for the parallel, C effective for parallel combination is C1 plus C2. The voltage here V1 equal to V2, meaning this is V2. The voltage here equal to V1 will equal to battery. And the charge stored on the capacitor 1 plus capacitor 2. Next, we need to calculate energy stored in capacitor. So the symbol is U. So normally we know that for the energy unit in joule. And then this is the equation to calculate energy in a capacitor. So half CV square or U equal to half QV, and the unit in joule. Now, we want to discuss a few examples related to the combination of series and parallel capacitor. Alright, okay, now from this question we have how many capacitor here? C1, C2 and C3. Be careful. C1 equal to C2 equal to C3. Meaning the magnitude is 2 microfarad. Okay, now how can we identify this combination are series or parallel? So again, okay, this is positive negative terminal. So the current will flow from positive to negative. So meaning the same current passing through C1, C2 and C3. Therefore, can we conclude that the C1, C2 and C3 are series? Okay, next step. So, after we know that the C1, C2 and C3 are series, so we need to draw a new diagram. Okay, combine C1, C2 and C3, so we get a new capacitance here, the effective capacitance here. Okay, involve 1, 2 and 3, and we can also write as effective. So how to calculate this effective capacitance? Okay, by using this parallel equation. So this is series. Okay, substitute C1, C2 and C3. So we get therefore effective capacitance 1, 2, 3 is 0.76 microfarad. Next, now refer to the diagram. So C1 and C2 are series or parallel. Yes, parallel. So we can state C1 and C2 are parallel. Okay, so next step, we need to draw simple diagram here. So from the complicated to capacitor, now we need to draw the simple one, single capacitance. So the single capacitance here will represent the combination 1 and 2, or we can write as a effective capacitance. So how? So by using the equation of parallel, so substitute C1 2 microfarad plus C2 4 microfarad. Therefore, the answer is 6 microfarad. What about for this question 4? Okay, now how many capacitors here? C1, C2, C3, C4. Okay, step 1. Identify this is series or parallel. Okay, so now first we need to look at the complicated combination first. Okay, so the complicated one is C1 and C2, C3 and C4. So this combination C1 and C2 series, and then combination C3 and C4 series. Okay, so combine them together. So we combine C1 and C2, we will get the new effective capacitance 1, 2. Combine C3 and C4, we get 3 and 4. Right? Okay, now, how to calculate combination of C1 and C2? So, for C12, combine as series. Okay, so we will get the answer is combination 1, 2 is 1 microfarad. So here is 1 microfarad. Combination of C3 and C4 also series. So we get combination C34 also 1 microfarad. Okay, now, next. We want to combine C12 and C34 here. Now looking at this diagram, the combination now is series or parallel? Parallel. So from here, we will get the single capacitance combination of 1, 2 and 3, 4. We can also write as a effective capacitance. So how to calculate effective capacitance here? So we know that the combination of C12 and C34 is series. Series. So we get the final answer is 2 microfarad. farad. Next, question number 5. Okay, we're looking at this diagram. So how many capacitors here? So we have C1, C2, C3, C4. Okay, step 1, we need to determine C2 and C3 first. Okay, so why we need to calculate C2 and C3 first? Why? Because of this combination are complicated. For the complicated combination, we need to solve it first. Okay, so why we choose C2 and C3? Because of we need to solve the complicated one. Okay, so now C2 and C3 are parallel. Okay, so when we combine C2 and C3, okay, so we get this combination C2, 3. Okay, now how to calculate C2, 3, combination of C2, 3? Okay, now by using parallel equation, so we get the value of C2, 3 is 4 microfarad. Okay, so 4 microfarad. So we get the new diagram from here. So we get new diagram. After that, now we need to combine C1, C2, 3, and C4. Now look at this arrangement or combination, series or parallel? Series. So when we draw a new diagram, so we will get combination of 1, 2, 3, and 4. Or we can write as C effective. So how to calculate combination of C1, 2, 3, and 4? So we use series. Okay, so final answer 0.44 microfarad. Question 7. Okay, how many capacitor here? C1, C2, C3, C4. Okay, for this circuit or this arrangement, okay, we need to start at which capacitor? 1 and 2 or 4 and C3 and C4? Which one? Okay, for this case, which capacitor away? Which capacitor away from battery? Which one? C1, C2 or C4? C4. Am I right? So meaning we need to settle or we need to solve C4 and C3 first. So we will start with combination C3 and 4 as parallel. Okay, so when we combine C3 and C4, we get combination or new diagram C3, 4 here. Okay, how to calculate combination C3 and 4 using parallel. So this is answer. Okay, next. We need to draw a new diagram here after C3, 4 combined together. So look at C1, C2 and C3, 4. Series or parallel? Series or parallel, class? Series. Okay, now when we combine all together, so we will get the new capacitor C1, 2, 3, 4. Or simple way, so we can write as C effective. So how to calculate C effective? Okay, using series equation. Now we substitute the value here and finally we get final answer. Okay, so make sure we draw from the complicated one. This is complicated one until the simplest diagram.